Alright, so we are picking up with our polynomial graphs that have multiple curves in them, multiple turns, multiple x-intercepts and zeros and things like that. We talked about end behavior. We've talked about how many zeros and turns a graph can have. We're now going to start describing the intervals where it increases or decreases. So when we're describing a graph, remember it always moves left to right. We can then describe what it does either as it increases, decreases, or is constant. So we want to keep in mind if it increases or if it decreases as we're reading this. Now a couple things to keep in mind and just some background knowledge on describing intervals. First thing, this sideways looking 8. Whenever you see that, that means infinity. What infinity means is that it goes on forever. So we're going to be using either negative infinity or positive infinity to describe this. A negative infinity means that it's going in a negative direction, which would be going to the left. So negative infinity means coming from the left. Positive infinity means going into a positive direction to the right. So that explains what direction we're either going to or coming from. And again, we always read this left to right just like a book. And we're going to describe our intervals as they increase or decrease. And these are going to occur at the breaks where our turns are. Now when we find these different things out, where it changes from increases to decreases, that's where our turns are, and we're going to end up with either a maximum point or a minimum point. So if we look over here to this problem here, we have y equals negative x to the third minus 2x squared minus 8x. And it's graphed out here for us. And this is in your notes. You can't kind of read this. But negative x to the third. It's an odd degree, and it's negative, so it starts up and finishes down. Now we want to be able to describe what this graph is doing. Now as we can see, again, we're coming from the left. It's going down, going down, going down. It's passing through our 0 of negative 1.414 comma 0 and coming down to this point right here. This is our turn. This is where it changes direction. So we have one instance going from here all the way to here. It then changes and goes up. And it goes up to this point, which is 0.816, comma 1.089. It changes direction again and then goes on and continues down forever, going in a negative direction. So we have one interval here, a second interval here, and a third interval to switch. So how we describe this? We could say that it starts by decreasing from negative infinity to our x value, which is negative 0.816. So it's decreasing there. It changes course and now it's increasing from this point, the negative 0.816, and it's increasing up to a positive 8.16. And mind you, I am using all the x values, not the y values. It then changes direction again and starts going down. It is now decreasing from 0.816, and it's no longer going to make a turn. We know the end behavior. It's going to end in positive infinity. This is how we can describe what our graph is doing. It's decreasing from the start on the left, which is negative infinity, and it's decreasing all the way to the point where the x is negative 0.816. It's then increasing from negative 8.16 to positive 0.816. And then changes direction one more time, and it's decreasing from 0.816 towards positive infinity. Positive infinity again means it's going to the right. And then we can describe that it has three solutions, where it crosses the x-axis. We can also say that it has a relative minimum, and relative means that it's not an absolute minimum, but it means there's a change of direction there. It has a relative minimum at this point here, which is negative 1.089. Your minimums and maximums are y values. It then has a relative maximum when the y value is 1.089. So there are two terms. So we had one relative minimum and one relative maximum. And you'll notice, if we have like 7 of these will just alternate from a minimum to a maximum, minimum, maximum, and continue forward. I'm going to kind of create one that where the numbers are a little bit easier. I don't know exactly what this graph what the values are. I'm kind of going to make them up. Here's our graph. Let's say it's going it looks like this. Let's say this point is negative 5 and positive 4. Let's say this point down here is negative 1, negative 3. This point here is 3, 7. Right now I'm not too concerned about the 4 zeros that we have. So I first look and I see that it's starting up. As I'm moving left to right, it's increasing to this point right here. So we could describe this as increasing. Again, we're starting from the left, so we start with a negative infinity, and it goes to negative 5. Make sure we get this. It then changes direction. And it's decreasing from that point. So I'm going to write decrease. Negative 5 to negative 1. Changes direction again. Increase from negative 1 to a positive 3. And then we have another turn here that finishes off in green. It's going to decrease from 3 to positive infinity. So again, we're going to start at negative infinity, and we're going to end with positive infinity every time. We're always moving left to right. Here we have a relative maximum. Relative max at negative 5. Down here we have a relative minimum. At negative 3, we have a relative max. Actually, this would be an absolute maximum. At 7. This one's an absolute maximum because there's nothing higher than it. It's not going up forever to the left. Going up or that. This would be an absolute maximum. Hopefully this helps. We'll continue to work on these throughout the week. Please replay if you need to. See you next time.